Today we're going to take a look at section 1.6, which is properties of real numbers. And to start with, I'd like to make sure that we're on the same page with a definition, and that definition is like terms. Terms are considered like terms if they have the same structure. And for the purposes of our discussion today, what I mean by structure is they have the same variable with the same exponent. So if the terms are like terms, they can be combined. And if the terms aren't like terms, then they can't. So the first example, 5D plus 2D. Are 5D and 2D like terms? Yes, they have the same variable, right? They don't have to have the same coefficient, so that's fine. And I can actually combine them. So if I have 5D and I have 2D, what does that combine to? 7D. Thank you, Nadia. Do you have a way to plug it into your computer, Caleb?
Yeah.
Okay. Now, number 2 is different. On number 2, I have some exponents. In particular, here's a y squared and a y squared. And here's a y. So y squared and y are not like terms. They're different sizes. That's actually what the problem is. If you were to think about sort of a visual imagery for them, y is a one-dimensional piece, right, like length kind of. Y squared is two-dimensional like area. I don't add length and area together. That doesn't make sense. So they're not like terms, but the y squared terms are like terms. They're both y squared. So I can combine those pieces. So I have 3y squared and 2y squared, which would be 5y squared. And then the piece that doesn't combine simply gets added on to the end, plus y. Okay, any questions on those two? Okay, so that was just to discuss and remind you about what like terms are, because we're going to be using them as we move through. But before we get too far down the road and with more examples, we need to talk about the properties that we are going to be using in this section. There are 7 properties of real numbers that we're going to talk about here in this section. The first one is the commutative property. The commutative property says that the order that we add things in doesn't matter, and the same is true for multiplication. Okay, so the order's not, it doesn't matter. And intuitively, you know that from elementary school, because when you were learning, say in first grade, your addition tables, right? Usually that's taught by taking like all the ones, and you learn 1 plus 2 and 1 plus 3 and 1 plus 4 and 1 plus 5, right? You do all those. And then you learn 2 plus 2 and 2 plus 3 and 2 plus 4 and 2 plus 5, all those. And you keep working your way up. And eventually when you get to the 9 pluses, that's terrible language right there, by the way. That's just awful. But once you get to the 9 pluses, you almost know all of them. You know what 9 plus 1 is because you learned it back when you learned 1 plus 9. And you know what 9 plus 2 is because you learned it back when you learned 2 plus 9. So the further along you get in that process, the fewer new facts you're adding on every time. So this is true for addition and for multiplication. It is not true for subtraction. And again, you know that. 5 minus 3 is not the same as 3 minus 5, right? So this is a very unique property to addition and multiplication only. The associative property is the next one. So the associative property says that when I add values that are grouped together, like they're all 3 added, it's A and B and C, it's all addition, that the grouping of the addition doesn't matter. So I could add the C and the B together first, or I could add the A and the B together first. The reality is I could even add the C and the A together first and it'd be okay. But basically I'm allowed to regroup the values when I have addition. And not only when I have addition, but also when I have multiplication. So sometimes it's preferable to add 2 numbers together or to multiply 2 numbers together as opposed to something else. Especially when things happen like, oh, when they multiply together, they give me 10. 10's a really nice number to then proceed forward with multiplication with or with addition with. So sometimes it's helpful to actually redo the ordering of values before we actually do addition or subtraction. All right, the third one is the additive identity. The additive identity says the following. There exists the number 0 such that any number plus 0, or that 0 plus that any number, I'm going to have to make that on the next line, equals the same value. The problem is that if I have to project with this projector this way, it doesn't work very well. Is that okay? Now it's really tiny. Yes, it says there exists 0 such that a plus 0 equals 0 plus a is equal to a. Again, that's very specific for addition. It's an additive identity. It doesn't work for subtraction is what I wanted to say. It doesn't work for subtraction, right? A minus 0 is a, but 0 minus a is not. Okay? There's also a multiplicative identity, and it says quite similarly, there exists the number 1 such that 1 times a is equal to a times 1 is equal to a. Make that a little bit slow. So I'm able to multiply by the number 1. It doesn't change anything. And the reality is we've been using this multiplicative identity property all throughout the fraction section. Every time we multiply the numerator and the denominator by the same value, right, we've multiplied by the number 1. And it doesn't change the value of the fraction. So we've been using this particular property already. Okay, 3 more properties to take a look at. We have the additive inverse. The additive inverse says for all a, there exists negative a, such that, where'd that's off my screen, a plus negative a, which is also the same as negative a plus a, is equal to 0. This is really talking about negative values, right? If I have 7, I have to have a negative 7. They add together to give me 0. So every number has a pair that it coordinates with, that when I add it to that value, I get back to 0. The multiplicative inverse is quite similar. It says for all a not equal to 0. I do need that on this one. There exists one over a, the reciprocal, such that a times 1 over a, or 1 over a times a, is equal to 1. So again, it's reciprocals, right? I can take any number, I can find its multiplicative inverse, otherwise known as its reciprocal. And the reason that it's the multiplicative inverse is because when I multiply them together, I get 1. Properties 1 through 6, pretty good chance that you use them in and out all the time and you never even think about them at all. They're so ingrained in what you do. We do it all the time. Number 7, for whatever reason, seems to stick in people's memories when they do it, and they remember the name. You usually don't remember the name of everything 1 through 6, but for some reason, number 7 they do. The distributive property. So the distributive property says that when we have A times B plus C, it equals A times B plus A times C. And it's actually true for positives or negatives. So where I put those pluses, put a minus underneath it. A times B plus or minus C is equal to AB plus or minus AC. It doesn't just work in that order, though. You could have reversed the order, too. Like, we could have the multiplication first. The addition first, the multiplication second, like this. And it works the same way. Sometimes people think about it as sort of drawing this arrow through values. So maybe that's one way you've seen it listed or drawn as well. That's the distributive property. Notice, the distributive property combines multiplication with addition or multiplication with subtraction. If you only had multiplication, right, just multiplication times multiplication, you'd actually be back at property number 2, right? It's all addition or it's all multiplication. So property 7, the distributive property, is about combining those operations together, and none of the other ones were about that. All right, so we're going to do some examples. Before we do, any questions on any of those properties? Okay, so we have the first 3 here. The first one says 4b times negative 2. And I suspect without even doing anything, you probably can just tell me what the answer should be. So tell me what the answer should be. Negative 8b. Now, I want to tell you that you used properties, but you didn't even think about it. You changed the order, didn't you? You did. You moved that 2 up there with that 4, right? You switched the order. That's the commutative property. You also switched the grouping, right? This actually says that I'm multiplying 4 and b together. And when you switched the order, you switched the grouping to multiply the 4 and the 2 together instead. So it's there, you just don't even think about it when you do it. Now the next one, what property am I going to use? It's the distributive property, right? Again, for whatever reason, that's the one we remember the name for. And we're going to distribute the 3 across the parentheses. And what will we get? 3x minus 6. Okay, so far so good? Great. Now number 5 is actually another distributive property. It doesn't quite look like all the properties the way they were written before because there's 3 things being added and subtracted, but it works the same way. We can distribute across 3 items just as easily as across 2. So I have 4 times 6, which is 24. I have 4 times negative 2a, which is negative 8a, and I have 3b times 4, which is 12b. And none of those terms are like terms, right? One's got an a, one's got a b, one doesn't have any of that. So there's no way to combine them, and we're done at that point. All right, any questions on any of those 3? I'm going to switch slides. Okay, number 6. Number 6 is another distributive one, just like the last 2. The thing that makes that one different, though, is what?
Fraction.
There's a fraction in there, right? So part of the reason that we did all those sections about integers and fractions is not because it's actually an algebra topic. It's actually not. So the integers and subtraction stuff, or not integers and subtraction, integers and fraction stuff we did is like late elementary school, early junior high math. But it comes back throughout algebra, and I want to make sure you remember those details because I don't want that to be tripping you up with algebra. So when you're taking a look at this problem, we do have to deal with the fractions again. So I actually have 12 times 2 over 3. And remember, I can write the 12 as 12 over 1, if that's helpful to you. Plus, now I have 12 times 2u. So what's 12 times 2u? 24u. So it's perfectly fine that I've sort of cleaned up the 12 times 2u part, but I haven't done it with my fraction part yet. All right, so I have 12 over 1 times 2 over 3. You have two options. You can multiply straight across the top, straight across the bottom, or you can look to see if you can simplify before you do the multiplication. So do you guys want to simplify first or multiply first? Simplify? Okay, so Caleb, what do you want to simplify?
3 and 12.
Awesome. What will they each divide by?
3.
Great. So 12 divided by 3 is 4, and 3 divided by 3 is 1. So this leaves me with a 4 and a 2 on top. 4 times 2 is 8. And then it leaves me with a 1 and a 1 on bottom. So what's on bottom? A 1. You can write it as 8 over 1 for the moment if you want, but you can also simply write it as 8. Eventually it should just be written as 8. That's the simplest way to write it. 8 plus 24u. So sometimes when we have fractions in the problem, they actually simplify out and we end up with whole numbers. Certainly wouldn't have to, but sometimes they do. All right, so number 7 has that same distributive property we've been seeing, but then afterwards you see that we have an extra subtraction step. So we'll do it a piece at a time. First we will do the distribution. So what is 3 times y? 3y, and 3 times 6 is 18. And then I have the minus y on the end. So you have to make sure when you're done with the problem, right, or when you think you've completed a step of the problem, that you're not actually, decide whether you are or you aren't actually done by looking to see if there's any like terms. And there's some like terms here, right? Yeah. I have 3y and I have negative y. So what is 3y and negative y? Or 3y minus y? 2y. So I have 2y and plus 18. You okay, Cole? Are you okay?
Yes.
Okay. Any questions on any of those three? All right. Let's take a look at the last two. Lots of distribution. Apparently that's the theme of today's lesson, distributing property. So we're going to distribute the 4 through here. And then we're also going to distribute the 2 through here. Okay, so a couple of things to notice is, because it's going to come up on your homework today, is how do I know what to distribute? Well, it's whatever's right beside it. So I'm not trying to distribute all of this through here, because it's not all right beside it like in a set of parentheses. It's just the 2 that's right beside it. So when I'm taking a look at distributing my values, I need to be careful about what I am and am not maybe distributing. So the first one I have 4 times k, which gives me 4k. Then I have 4 times negative 7, which gives me negative 28. Now I'm distributing a positive 2. So positive 2 times positive 6 gives me 12. And then 2 times negative k would give me negative 2k, right? So that's all the distributing parts. Now we're going to see if we have any terms that are like terms to combine. So what do you see term-wise that are like terms?
4 and 2k.
Yep, the 4k and the negative 2k. What do I get when I combine those? 2k. Any other like terms? Yeah, the negative 28 and the 12. So what is, again, this is that integer section, right? Harkening back to section 2. What is negative 28 and positive 12? It is negative 16. It's negative because the 28's the larger value and it's negative, and then 28 minus 12 because they're different signs is 16. Show your work. Show your work. Because if you give me the answer of 2k plus 40 or minus 40 here at the end, and I don't know the work in between, it's really hard to award you any partial credit. I don't know what you did wrong necessarily from the steps because you didn't show any. But if that's the only thing that you've missed and I can see the work, then you can get most of the credit for the problem and only miss a portion of the points. Make sense? All right, last problem. This one doesn't have any distributing, but it does have an awful lot going on. I need to look and see what terms are like terms that I could combine. So somebody give me a suggestion of terms that I can combine here. Fabulous. The x squared terms. I have 6x squared and negative 2x squared. Those combine to give me what? 4x squared. What else do I have that are like terms? Okay, I've got a negative x here, and I've got a negative 3x here. So what is negative x and negative 3x? Negative 4x. Again, this is integers, right? It's a negative 1 and a negative 3. They're both negative, so it stays negative, and we add the values. 1 plus 3 is 4, so negative 4x. And then the last thing we have is what? Yeah, then positive 2 and then negative 7. And if I combine those, yeah, you're right, Caleb, you get a negative. There we go, 5. Okay, any questions on either one of those? All right, go ahead and grab your homework then. Let's take a look. You probably have time to finish most of it before you leave. There are a couple on there that are tricky that don't look exactly like mine, so it would be a good idea for you to take a look through those. Elijah. You did not print it off. Do you have access, though, to see it on the screen? You should be able to pull it up, and you can use a sheet of paper to do it on instead this time, which will work just fine.